Hi, everybody. Uh, This is block 4 after you took your test earlier today. I'm making this video on the first section that we are going to do on Thursday. So I'd like you to come into class ready to go on this, having watched this at least once. There's a Google form that goes with this that I want you to submit ahead of time. We're dealing with systems of equations, which you did in Algebra 1. So as kind of a review, what we have is we have a system. We have two things. A system are things that work together for the result of like one thing happening. So this whole system of the human body makes the person go. So what we have is at least two equations, and we want to find the point that they share. And one way to do it is by graphing. So over here, I've got a coordinate plane. The dotted lines are my two lines that you could graph. Where they cross, that point is the solution. That's the answer. So that when you are finding an answer to a system, your answer is a point. Okay? That's important to have. There are three ways, graphing being one of them, but typically not the most efficient. We don't really want to graph, although you could always do a little quick graph to give an example of where the lines might cross. Elimination and substitution are the two we do primarily. I'm going to do substitution first, although my favorite and probably the most important to learn is elimination, and I'll do that one last. So for substitution, here are the two equations. Our answer will be a point that make both of these statements true. So that when we plug x and y in for both of these, they'll make a true statement. So the key to substitution is having one of the variables by itself. And that's this one, because we could change this around. Make that equation y equals negative 2x plus 7. Now, if y equals this, what you can do is take that and substitute it in for that y. So our new equation up here becomes 5x minus 2 5x minus 3y. Sorry, this should be a 3. I apologize. 5x minus 3y is 23. Well, y is going to equal this. So now we have to distribute and solve it. So 5x minus, is going to be plus 6x minus 21 equals 23. Remember, it's negative 3 being distributed. 5x plus 6x is 11x. Add 21 to both sides. We get 44. So x equals 4. So up here, x is equal to 4. And then, once we have one of the two missing points, the coordinate points, substitute it back in. So, if x is 4, put it in right here. 5 times 4 is 20. 20 minus 3y equals 23. Okay? So take away 20. Take away 20. Negative 3y equals 3. Y equals negative 1. Okay? So that's the point that makes both of these true, and that's your answer. The thing with this one is, to make it work, you have to have this by itself. And if you don't have a variable that's by itself, and there's a coefficient, you're really going to struggle. That's why we like elimination. In this case, I made it easy, where both of the y's have a 3. In class on Thursday, we're going to go through one, and we're going to do a lot where none of the coefficients are the same. But in this case they are, because you have to get them to be the same. So when we get a positive 3y and a positive 3y, our operation is going to be subtraction. Because 3y minus 3y is 0y. We are eliminating, hence the name of the strategy, we are eliminating the y's. 3y minus 3y. 5x minus 8x is negative 3x. Negative 19 minus negative 25. That is tricky. Negative, negative, negative. Minus a negative is positive, so that becomes positive 6. So negative 3x equals 6. X equals negative 2. So negative 2 is our x. Substitute it back in, and let's get our answer. So 5 times negative 2 plus 3y equals negative 19. This is negative 10. So add 10 to both sides. 3y equals negative 9. Y equals negative 3. And that is the point that both of these share. Okay? So the key to this is having the same coefficient here. I'm going to do a what-if situation with you and change the problem down around a little bit. What if this was a minus 3y? So I have positive 3y, I have negative 3y. What I can then do is add. Because positive 3 plus negative 3 eliminates them. But then I would add here, and I would add there too. I'm not going to go through the whole problem because it's going to work out with a fraction that's really yucky. And I don't like that. But the point is I want to show that you don't always subtract right here for that. Last thing I want to show, because I still have 2 minutes left on my video. So there's one, and then here's the other. I have no idea what the answer is to this, but all I'm doing is showing you. I got a 3, a 2, a 6, a negative 5. None of those are the same or opposites that we could add or subtract to. So we have to make it the same. And you can see that this is a 3 and this is a 6. If I multiply 3 by 2, I'm going to have a 6. So what I do is multiply everything by 2. And that's math legal to do that. Multiply everything by 2. And 2 times 3x is 6x. 2 times 2y is 4y. And then 2 times 8 is 16. So now you would use these two equations. And you would subtract here, 6x minus 6x. I'm not going to go through it because the answer is going to be kind of yucky with the math. We're going to get a fraction, and I don't want to play around with fractions. Okay, so these are the things you need to be ready to do on Thursday because of the activities that we have in class. See you then.